Everyone, welcome back. We'll continue our discussion of duration. There's a mini exercise in this video. Let's get into it. So we're still working off of chapter 20. And in the previous video, we computed a bond's Macaulay duration, which we said was a weighted average maturity of the bond. Right? This 4-year bond, it matures in 4 years, but we don't have to wait 4 years to receive all the cash flows from the bond. Right? Some of them happen earlier. And so if we weight each present value of the cash flow as a percentage of the total bond price, the weighted average maturity is 3.589 years. That's the Macaulay duration. Let's move on and talk about modified duration, which is a more heavily used duration measure and a more tangible measure of interest rate risk. So if we take the Macaulay duration, D, in the terminology of the notes, and divide it by 1 plus the discount rate, that's the modified duration, D star. D star. So this is a measure of interest rate sensitivity, and it's like an elasticity. Benninga, the textbook author, calls it the price elasticity of a bond. I've never heard anyone call it that in the industry. But what it is it tells us how much a bond's price changes as the yield to maturity, the discount rate changes in percentage terms. So let's compute the modified duration, which is just the Macaulay duration divided by 1 plus the yield to maturity, the discount rate, right? And here it is right here, 3.369. And if I had to interpret that number in words, right, I'd say this: a 1%, a 100%, 100 basis point change, a 1% increase in yield to maturity is associated with a 3.369% decrease in price. So it's an approximation. If interest rates rise by 100 basis points, by 1 percentage point, this bond's price is going to fall by about 3.369%. So you can see that higher modified duration means more interest rate risk. Yeah? All right. So we'll use modified duration as a measure of interest rate sensitivity. And let's actually look at this other duration measure, dollar duration. Instead of measuring the change in a bond's price as interest rates change in percentage terms, like modified duration does, we could measure it in dollar terms. Not in the textbook, but it's used all the time, so let's do it. And so what we would do, why don't we make a little place to put it, dollar duration. And what it is if you just take the modified duration divided by 100 and then multiply it by the bond's price, we end up with about 35.43. So dollar duration, a 1% increase. Let me write it again. A 1% increase in yield to maturity is associated with a $35.43 decrease in price. So dollar duration measures interest rate sensitivity in dollars. Great. So we'll have to keep all these measures straight. Sometimes you'll see just the vague reference to a bond's duration, and it can be kind of unclear what's being referred to. It's a safe bet that it's probably modified duration. But if it's ever not clear, especially on an exam, feel free to come talk to get in touch, and I'm happy to clarify. So let's see how to compute these a little bit more easily in Excel. There's a couple Excel functions to use. There's an equals duration function and an M duration for the Macaulay and modified durations, respectively. And then dollar duration, there's not really an easier way to compute it, but it's not too bad. This is pretty much what we did, right? Let's look at Macaulay duration. So what we need are a bond's settlement date and maturity date. And so with actual bonds, we usually don't buy bonds on the date of a coupon payment. And so the function includes settlement date and maturity date to adjust for the fact that you might buy a bond like 30 days into a 6-month period before the next coupon payment. But let's see how the function works. Equals duration And let me just align this stuff left so that the text shows up a little bit easier. You don't have to do this, but let's see. So equals duration. It takes as its argument the settlement date, comma, and then the maturity date. Right? For a 4-year bond, I just put 2 dates 4 years apart. I like putting January 1st just for illustrative purposes. It's easy to understand. The coupon rate is right here. Coupon is 8%. Yield to maturity is here. The frequency, annual, semi-annual, quarterly. This is an annual bond. You can do it with semi-annual bonds. The last argument is optional, but it's just there's different day conventions for measuring how many days accrue interest between coupon payments. If you want to talk about that more offline, just come let me know. But the duration function, if we've done our work right into the cell directly to the left of it, should get the exact same, return the exact same result as what we got when we computed it sort of the long way. Right? And then similarly, the modified duration equals M duration has the exact same arguments, equals M duration. Settlement date, maturity date, coupon, yield, frequency, annual. And then you could put actually on, if you buy a bond on a coupon date, it doesn't matter what basis you put in. So you can leave let's just plan to leave the argument blank if we like. But actually, whatever you choose won't affect the final result. And so here's the modified duration. And there's not really an easier way to find the dollar duration other than taking the modified duration divided by 100 and then multiplying that whole thing by the price. Just careful with these parentheses, right, for the order of operations. So your mini exercise, we've got another bond down here, great bond, looks like a 10-year bond that has a 4% coupon rate. And then here's the yield to maturity. Mini exercise, I want you to report the Macaulay duration and the modified duration of this bond on the mini exercise using whatever method you prefer. Right? Maybe the duration and M duration function would be easiest. So in the next video, we'll talk about how to use this interest rate sensitivity measure to manage a portfolio of bonds and why we should care about that kind of thing. All right, thanks for tuning in as always. Talk to you soon.